see on the doors of the room or behind me. The QR code will directly address you to Converso web app, where you will be able to select the interpretation language. To listen to the translation, it is necessary to have a copy of headsets. So please kindly use your headsets. If you do not have them, you can ask them to the volunteers in the room. Please follow us on Instagram, where on a daily basis we talk about the festival. Please mute your electronic devices and participate to the initiatives. Thank you for your attention and have a good day.
Buonasera, buonasera a tutti.
Good evening to you all and welcome. Can you all hear me? I have the enormous pleasure this afternoon of introducing very briefly the presentation that will be held by our guest, Steve Mithen. Welcome, Steve, to Bergamo Scienza. He will be discussing with us of a very special, unique subjects and hopefully very fascinating for us and for you. Steve is an archaeologist as a background. It's also his job. He's very much committed on the field. He works in sites in Scotland, in Jordan, in many other places of the world. In particular, he deals with a specific period, which is that straddles, let's say, the last groups of hunters-gatherers that have lived in the Middle East and in Europe, and then the arrival of the Neolithics. But Steve, who works at the Reading University in the UK, has a very interdisciplinary background. He uses archaeological data, but also biological, genetic ones. He combines them to try and reconstruct the past history of the populations of our ancestors, as we could say, direct or indirect ones. Steve has become very well known in the mid-90s for a book entitled The Prehistory of the Mind. And then for another one that's been translated in Italian, by the way, another 2005, which is The Single Neanderthals. This is the title translated in Italian with Il Canto degli Antenati. And he's now working on another text that he will be talking to us today that's called The Invention of Words. So on the evolution of the language. What is the main topic? And after this, I will leave the floor to Stephen. So what is the main topic that Steve deals with? It's the archaeology of the mind of the Homo sapiens, but also Homo sapiens compared with the mind of other human species that have lived up to recently, as we know, in Europe too, such as the Neanderthal or the Denisova in Asia. Why archaeology of the mind? Because currently, for those like us who study this, there's a big question mark still waiting for an answer. Homo sapiens was born in Africa between 200 and 300 millennials ago. After some millennials, he leaves Africa. He starts occupying Eurasia, and then he will get to Australia too, then to the Americas. For a long period of time, he coexists with other human species. We will be talking about this even, obviously, mixing with other human species. But then Homo sapiens starts having, let's say, new unprecedented behaviors, rupestrin drawings, burials, ornaments of the body, new technologies, objects with some signs on them that obviously meant to say something. So all that we associate to the so-called symbolic intelligence. What has happened? Why is it that Homo sapiens changed behaviorally? And this is what led us up to here, and which, amongst other things, is also connected to the extinction of all of the other human species that have all disappeared up to surviving to 40,000 years ago, practically. So Steve deals with this mystery of the archaeology of the mind, how the human brain has changed up to the point of getting to the modern human intelligence. And we know what this has led us to, and it's the one that we still use, or hopefully we should still be using now. Okay, if we don't become extinct before, as we're trying to do apparently. So Steve, welcome again. So he will give us a general overview, very concise overview of what he's been doing, and then there will be time for some questions. My questions, but your questions too. So get ready to interact. Steve, the floor to you. Thank you very much for being here.
Buonasera a tutti. I'm sorry, that is all of my Italian. And I'd like to thank the translators for making my talk accessible to you this evening. I'm going to be talking about the Neanderthals, some of whom you can see on the screen here, at least their reconstructions. I'm going to explain how, in so many ways, they're so similar to us, but in some critical ways, they are very different. And in learning about that difference, we learn about ourselves today. Now, when I talk about the human mind, I don't only mean the brain. I adhere to the view of the mind as an extended and a distributed entity. Now, by extended, I mean that we use technology to extend our mental capacities. What we remember, for instance, we use our phones to store people's phone numbers, or we use a computer to do arithmetic that we can't do in our mind. And by distributed, I mean that we often rely on other people. So, for instance, I don't need to remember lots of family birthdays or how to use the TV remote because my wife remembers those things and I just ask her how to do them. So our mental capacities are distributed between us. And of course, our words that we use are both a form of extended mind because sometimes we use words to anchor complicated concepts in our minds without which we just wouldn't remember or be able to talk about or communicate them. And we also use them to distribute our minds by telling other people what we think. Now, I think the Neanderthals also had extended and distributed minds, but of a rather different nature to those that we have today. Now, in this slide, we see some of the differences between the Neanderthals and modern humans. And of course, all of us in this room, in fact, everybody on the planet today is a modern human, a member of the species Homo Sapiens. The Neanderthals evolved in Europe about 300,000 years ago, and their populations spread into Central Asia, and they became extinct about 40,000 years ago. Our species, Homo Sapiens, we also evolved in Africa at around the same time. Our particular species characteristics became evident. But we seem to have undergone quite a substantive behavioral and cognitive change at around 80,000 years ago, and we dispersed from Africa into Europe and into Asia. And as we dispersed, gradually, all the other types of humans that were alive on the planet at that time, which wasn't only the Neanderthals in Europe, there was also the Denisovans in Asia, and probably Homo erectus still in Asia, they all became extinct. Now, in this picture, you can see how the Neanderthals on your left and Homo sapiens on your right, we evolved from a common ancestor in Africa known as Homo heidelbergensis. And at around 600,000 years ago, the trajectories towards Homo sapiens in Africa and Neanderthals in Europe diverged. You can also see how that trajectory towards the Neanderthals in Europe also split around 250,000 years ago, creating a species known as the Denisovans. Now, we don't actually have much skeletal remains of those at all. We only know them from ancient DNA, and I'm going to talk in a few moments about the huge significance of ancient DNA in our understanding of the Neanderthals today. Now, the Neanderthal time and world stretched for more than 250,000 years. They were a remarkably successful species, living primarily in Europe. And you can see on that map there, in that blue extent, that's where the populations extended, all the way into Central Asia, and also down to the Near East, where we've got excellent remains of them from modern-day Israel. They lived through quite dramatic climate and environmental change. In the graph at the bottom, you can see the changes in temperature over the last 300,000 years ago. When that line is at the top, it means it's a warm period, and interglacial, that's like we're living in at the moment. When it's low down, it was an ice age. So when the temperature was low, Northern Europe was covered in vast ice sheets. Tundra extended all the way down, almost to Southern Europe. Northern Italy here would have had some woodland, but would have been very dry. In the warm periods, in the interglacials, woodland and forest spread. Northern Italy would have been a thick forest with wild boar and deer and a wide range of games. And the Neanderthals lived through this change of environments. They must have adapted to them very effectively. They were really effective hunters. In fact, we call them as top predators. Their physique, they were shorter than us, more muscular, more stocky, certainly a lot stronger. That seems to be an adaptation to physically demanding lifestyles, as well as often living in rather cold environments. By top predators, I mean we know that they were hunting mammoths and woolly rhino. They were hunting horse and bison and deer. These are the animals that spread across the European tundras and woodlands. Sometimes they also hunted cave lions and possibly wolves for their pelts and their furs. We also know that the Neanderthals themselves were sometimes hunted by lions and certainly scavenged by hyenas, I will see in a moment. And to do that hunting, they made fabulous long spears, as well-made, designed as some modern javelins, as these ones discovered 350,000 years ago at the site in Schöningen in Germany illustrate. They also made short thrusting spears, making beautiful stone points and binding them onto wooden halves using vegetable twine, using the guts of animals, and making birch bark resin. So technologically, they were very skillful and quite sophisticated. We also have good reason to believe they had extensive knowledge and use of plant foods. Now, plant remains don't survive as well as animal bones in the archaeological record, but we've got various sources of evidence to suggest they had really detailed and extensive knowledge. So, for instance, in that little jawbone you can see there, which comes from a site of El Sidon in Spain, it dates to about 50,000 years ago, and it's the jawbone of a Neanderthal. And from the calculus, or the dental tartar, that had grown up on the teeth, we've been able to take some of that tartar off and extract from that ancient DNA still surviving in it. And that tells us about the foods that the Neanderthals were eating. And it shows that this particular Neanderthal had been, his diet would include pine nuts and mushrooms and moss. So they weren't only reliant on hunting animals. And one of them, from El Sidon, this Neanderthal had a very nasty dental abscess. The Neanderthals often had rather bad teeth. And when we looked at his calculus, it had the remains of the poplar leaves on. Now, poplar is not really good plant food to eat, but it does contain salicylic acid. That today is the main ingredient of aspirin. So this Neanderthal, they may have had that medical knowledge and been self-medicating. So we think they had fantastic knowledge about all the plant foods and the other uses you could do with plants in their environment. Now, their technology is only known really through their stone tools. Most of their tools were probably made from wood and antler and bone, from leather and hide, and probably woven plant materials. But that rarely survives archaeologically. Their stone tools survive in abundance. We have hundreds and thousands, probably millions of them, coming from various cave sites and open sites excavated throughout Europe. And we know they were very, very skillful workers of stone. You can see on the picture here something known as a Levallois point. Now, this has been knapped from nodular flint with great skill, so that with one blow they could remove a sharp point, as you can see there, which would then have been hafted onto a spear. So they have huge skill. The strange thing is, however, their technology didn't change through time at all. It remained really stable. Now, we normally think that when you're skillful at making something, you're always innovating and changing. Look how our phones have changed over the last 20 or 10 years. People keep fiddling, inventing something better, improving it. The Neanderthal technology remained really stable. On the right of the slide there, you can see a long sequence of deposits in Tabun Cave, which is in Israel. That dates 250,000 years ago at the base to 45,000 years ago at the top. Throughout that time, more than 200,000 years, Neanderthal technology hardly changed at all. Despite all the changes in climate and environment, the animals are hunting, the plants are gathering. And we can take collections of stone tools, whether they're found in Italy or France or Spain or even in Central Asia, and they look very much the same. So this is very strange. We've got Neanderthals who are really clever at making stone tools, but they don't innovate and change through them through the time. It's a mystery. Now, we also know that the Neanderthals were most likely highly socially intelligent, or they had a high level of emotion intelligence. Now, how do we know that? Well, for a start, we know they had large brains. Their brains were as large as ours today, on average about 1200 cc capacity. And there's very strong evidence from the study of primates, for instance, that the increase in the size of the brain through time is principally driven by improved social intelligence. The ability to make friends, the ability to build alliances, the ability to work out what somebody else is thinking. These take a great deal of neural capacity and is the main driver for the enlargement of the brain. But we can also look at the Neanderthal activities and know that they would have required lots of cooperation. They were big game hunters. Now, if a group of us are going to hunt, say, some bison, we really need to trust each other, because I need to know I'm going to throw my spear at the right time when you're distracting the bison or so forth. Otherwise, I'll get trampled and you'll live. So trust is hugely important, as is in food sharing. And we also know that the Neanderthals cared for the sick and the disabled. We've got several examples where Neanderthals have got severely injured, and yet they lived for many years after that. So they must have been cared for. So those strong emotional bonds. And then some Neanderthals were buried, and we suspect that is caring for somebody who they'd loved and wanted to remember, and didn't want the hyenas or the cave bears to come and scavenge on the body. So there's strong evidence for caring in the Neanderthal society. Now, in my 2005 book, The Singing Neanderthals, I argued that singing and dancing together was a really important way that Neanderthals built trust, built social bonding, built cooperation, just as we do today. So, Neanderthals are very highly socially intelligent. Now, our species, modern humans, we dispersed out of Africa about 80,000 years ago. The date isn't exact. Some say 80, some say 60, some say a bit earlier. We evolved in East or South Africa, dispersed out of Africa into Asia initially, South Asia, into Southeast Asia. From there we built boats and colonized Australia, and eventually out into the New Zealand. Some of populations went north, they crossed the Bering Straits, and within a few thousand years had spread all the way down to Tierra del Fuego. It's an amazing migration through all sorts of different environments, different environmental challenges, needing new technology to reach these far destinations from Africa. And some groups spread into Europe quite late, not until around 45,000 years ago. Now, as we spread around the world, our species interbred with the existing humans. So on several, perhaps many occasions, there was interbreeding between Homo sapiens and the Neanderthals. We don't really know how often, we don't really know what sort of form that sex took, but certainly fertile offspring were born, and that has meant that we have all inherited Neanderthal genes, okay? So all of you sitting out there and us on the stage were on average between 2 and 4% Neanderthal, because we've inherited their genes. Also, there was interbreeding with the Denisovans, and modern humans, especially in East Asia, have a lot of Denisovan genes. So this interbreeding is very important. It's another sign that Neanderthals and Homo sapiens were, in fact, very similar. When the modern humans came into Europe, at around 45,000 years ago, they spread quite rapidly, all the way across the continent. They brought new technology with them, especially these split base bone points, probably really effective hunting weapons. They were making stone tools a different way. They were making long and thin blades. They also were making a lot of art, figurative art, carvings of animals, and eventually cave paintings. And they spread across Europe quite quickly, and maybe for about 2,000 years, maybe 3,000 years, there were both the Neanderthals and the Homo sapiens in Europe. And the Neanderthals then went extinct. Can we change? We know that the modern humans were living with high population numbers. In this slide, there's just graphs showing how archaeologists have measured the number of archaeological sites, the quantity of stone tools, the numbers of animals that were butchered, undertaken by the final Neanderthals and the earliest modern humans. And there's about a tenfold difference. So we think that there were about 10 times as many modern humans coming to Europe than there had been Neanderthals. And when modern humans were there, the Neanderthals went extinct, they continued thriving and changing their technology constantly. So around 20,000 years ago, the last ice age reached its height. Glaciers spread from northern Europe. The northern regions across northern France became tundra. Trees began disappearing. Northern Italy became very dry and barren. And yet, the modern humans adapted to this. They made new types of tools. They made shelters out of mammoth bones. They invented musical instruments, and they did digital painting. Probably these are social activities to help with all the social connections. So modern humans were very good at constantly changing their culture. And of course, they've been doing it ever since, which is why today we're sitting in the city of Bergamo with all its wonderful architecture that I've so much enjoyed during the last 2 days. So here's the key question. Why did we survive and the Neanderthals go extinct? Now remember, the Neanderthals had evolved in Europe. They were adapted to living in these northern environments. They'd been doing so for more than 250,000 years. They were physiologically and culturally adapted to these landscapes. But Homo sapiens was an African species. We'd evolved in low latitudes, had no experience in living in northern tundras, in boreal forests. We were used to savannas. So how was it that we're able to come and replace the Neanderthals so very quickly within a few thousand years? Now, before going on, I want to introduce you to some Italian Neanderthals. These are a few Neanderthals who lived in Italy, and they are some really important fossil skulls and archaeology. And the first one is known as Altamura man. And you can see him there. He is still encased in calcite within a cave in southern Italy. And the calcite, it's got a particular formation. It's known as popcorn calcite. But to me, it looks like he's living covered in a blanket of pearls within this cave. Altamura man is found in the modern town of Altamura in southern Italy, in Lamalunga cave. I've never actually been to this cave yet. I do hope so. I'm going to next summer. It's a cave with lots of passages and deep little caverns in. And the fossilized skeleton was discovered in 1993. It's of a young adult male. It's really well preserved. It's almost complete. And it seems what happened is this Neanderthal was within the cave and he fell down a hole and became trapped. And there he slowly starved to death. He couldn't get out. There's no associated stone tools for him at all. No trace of any other individuals. He seems to be a young male just out exploring, wandering around this cave, fell down a hole, got trapped. Now, geologists have dated the calcite that formed over his bones to between 172 and 130,000 years ago. So that's when he lived, probably about 150,000 years ago. Because it's so embedded in the calcite, only one, or rather 3 fragments of bone have ever been removed. There are 3 fragments of scapula that you can see in the photo here. And actually, we've managed to extract ancient DNA from that scapula. What we do know is quite a lot about his teeth, because using the cameras that surgeons or dentists use, we'll be able to put these on cables down into the cave and have a good rummage around inside his mouth. And we can see that he, for instance, was missing 2 teeth before he died. And from one of the gaps hadn't healed yet. He had an accumulation of dental calculus, like we saw in the El Sidon cave. And some of his roots was exposed of his molars. So it looks like he had fairly bad gums. He had a thick growth of bone on his palate. That's probably quite harmless. We find that in modern humans as well. And the back of his jaw there's a big space called the retromolar space between the last molar and the start of the jaw. That's a common feature of Neanderthals. That helps prove that this was indeed a Neanderthal. Let's look at another of your Italian Neanderthals. This one comes from Guattari, which is in the Cicero Peninsula. This skull was discovered in 1939. It dates between 60 and 50,000 years ago and is also of an adult, but we don't know whether it's male or female. Now, do note on this one the very large eye sockets. There's also a very large nasal cavity and these big brow ridges of the Neanderthals. They're very distinctive features of the Neanderthals, and they differ from the shape of our skulls today. Now, this skull was found when workers were extracting stone. And the skull was said to have been found within a circle of stones. And the back of it, rather the hole at the base of the skull, which is known as the foramen magnum, had been enlarged. Now, it was initially thought other Neanderthals had done that to extract the brain as a form of cannibalism. Now, we doubt that now, because looking at this skull in more detail, we can see lots of hyena tooth marks on it. So we think hyenas were feeding on this dead Neanderthal. But elsewhere in Europe, there was definitely Neanderthal cannibalism happening. We've got a lot of Neanderthal bones with stone cut marks on, showing that they were being deliberately defleshed. In 2019, there was new excavations in Guattari, and they found 9 more Neanderthal remains, 8 of them dating between 50 and 68,000 years ago. There was also the bones of hyenas, elephants, rhinoceros, and capers, animals that were living at the time. And this really confirmed that this cave had been a hyena den. And the hyenas had been dragging in dead Neanderthals to feed on them or to feed to their hyena cubs. Possibly they'd been hunting Neanderthals as well. And the third Neanderthal I want to introduce you to is one that comes from Sacco Pastore, and I think that means the shepherd's bag, translates. This was a gravel quarry on the outskirts of Rome, and in 1929, a complete Neanderthal skull, a really well-preserved skull, was found within the quarry, within sediments that have been dated to about 130,000 years ago. Then in 1935, there was another fragment found. You can see here visual reconstructions of them. And on your right is what's known as the endocast. Now, that is a mapping of the inside of the skull that captures all the blood vessels and the folds of the brain. So it really gives us a really good insight as to what the Neanderthal brain had looked like. And this one is quite typical. Actually, it's quite an extreme form of the Neanderthal brain, because it really is quite flat. And we'll see that's important in just a moment. So let's get back to our key question. Why did we survive and then Neanderthals go extinct? Well, does the answer lie within the genes? The last 10 years has seen a revolution in what we call paleogenomics, the ability to extract ancient DNA from skeletal material. This happening soon after the ability to reconstruct or to identify the whole of the human genome. In 2014, the first complete Neanderthal genome was sequenced. And that came from that tiny little toe bone there that was found in Denisova Cave in Siberia. So toe bone of a Neanderthal, and from that, the complete genome of Neanderthal was extracted. And since then, many Neanderthal genomes have now been reconstructed. And from that, and by comparing those with those of Homo sapiens today, we know that on average we all carry between 2 and 4% of Neanderthal genes. That has come from interbreeding. And the intriguing thing is that different people have different bits of that Neanderthal genome. And were you to add them all together, something between 30 and 70% of the Neanderthal genome still survives in the modern world. It's a truly remarkable finding. So in many ways, the Neanderthals still live on, but within us. I think that's really profound. What have we learnt from the Neanderthal genome? Well, first of all, that they have a really low genetic diversity. That means each of the Neanderthals were quite similar to each other, far similar to each other than all of us are today. They're also highly interbred. Now, that Neanderthal from Denisova, we know that her parents had been half-siblings of each other. And in her recent past, her close relatives were common among her recent ancestors. So there's lots of inbreeding between these Neanderthals. And we know what inbreeding does. Accumulation of deleterious mutations. It increases genetic drift. And geneticists have estimated that Neanderthals probably had a 40% lower fitness than modern humans because they were carrying around lots of bad genes that, had they not been inbreeding, would have been selected out of the populations. It might be the case that their incentive to inbreed, their incentive to interbreed with modern humans coming into Europe was an attempt to increase their own genetic diversity. Their own hybrids are likely to have low fertility, as indeed what all this suggests is that the Neanderthals were quite a fragile population and were actually sensitive to climatic and environmental change, and probably sensitive to a new population coming in, competing with them in the landscape. What did we get from interbreeding with the Neanderthals? Well, actually, we seem to have got quite a lot. In many areas of our genome, there was selection against taking in Neanderthal genes. But we know that some of the genes we've inherited have actually been favorable to us, either in the past or the modern day. So some of the genes we inherited gave those modern humans immunity to particular diseases that they would encounter in Northern Europe that they hadn't encountered in Africa. It improved their skin adaptations to the very light northern environments. And we know that many of us carried genes relating to our hair. It's said that Neanderthal genes increase the propensity for baldness. I don't know why that would be a good thing, but it's often described as a good thing by the geneticists. We've inherited genes for stronger bone density, for increased lung capacity, and for a younger age at menopause. These have all been inherited from the Neanderthals, and they interact in a complicated way with our existing genetic material. So these seem to have enhanced our adaptation to higher latitude environments. So we benefited, and this helped the spread of modern humans into the northern latitudes. There's two areas in the modern human genome where we don't find any Neanderthal genes at all. They are called introgression deserts, because Neanderthal genes just couldn't penetrate them. One is the testes. In looking at all the genetics of modern humans associated with the testes, there's no trace of any Neanderthal genes there at all. Now, that's probably because the Neanderthal genes in the area would have decreased the fertility in males within modern humans, and therefore they were selected against. The other area that we don't find any Neanderthal genes is in the human brain. This is also an introgressant desert. And that's really very fascinating for when you start thinking about the mind and cognitive capacity. So let's have a little look at the modern human and the Neanderthal brain. Now on this slide you can see the Neanderthal brain on your left and the modern human brain on the right. They are the same capacity. They would have both been selected for enhanced social intelligence. The modern human brain is much more globular in shape, which is then reflected in the globular shape of the skull. Now, it's been recently argued that the amount of neuronal capacity in the Neanderthal brain and the modern human brain were devoted to different tasks. Look at the Neanderthals again. They had these really big eye sockets which correlate with having really big eyes, and for that, more of their brain would have been devoted to a visual cortex. So to enable those larger eyes to be used effectively required more brain capacity. Equally, they had a much larger body mass than modern humans, so more of their brain capacity seems to have been used for just managing the body, daily maintenance, control of it. This leaving less amount of the brain available for social engagement, for social tasks. So whereas both are social intelligence, that may have been rather greater within modern humans. What are the particular gene areas in the modern human brain that the Neanderthals could not penetrate? Now, one really key area in the modern human brain is a set of genes which they guide the axons of neurons. Now, as you know, the brain is composed of billions of neurons, and they send out tentacle-like things called axons, which connect with other neurons, and they build all our neural networks in our brain, which allow us to do particularly complex tasks, like speech and language, or abstract thinking. Now, in modern humans, geneticists are gradually identifying the key genes for these. These are genes known as FOXP2, SLIT2, ROBO2. And what these do, these guide the axons to enable them to make some connections and avoid other connections. Now, the Neanderthal genes couldn't penetrate this area at all, which suggests that they lacked the genes that were as effective, or even more effective than this. The Neanderthal genes were selected out. So sometime after that split from the Neanderthals from the common ancestor, we seem to have a genetically driven modification of a complex network for cognition, giving us a degree of neural connectivity that Neanderthals probably lacked. And then one of the most important discoveries was just announced less than a month ago in a really important paper in the journal Science. It was found there's a particular gene called TKTL gene, and we know that that is crucial to building neurons in the brain of a fetus. Now, it was found that after 500,000 years ago, the variant of that gene leading to modern humans had a mutation that changed one single amino acid on it. And it's found that that mutated gene ends up creating, through quite a long biochemical pathway, a higher density of neurons in the brain than does the version of the gene that the Neanderthal still maintains. This has been tested in the laboratory by making what's known as brain organelles, which are like little mini brains in Petri dishes, and feeding them with the two types of genes and measuring the amount of neurons that are built. So as you can see in this diagram, on your left, we've got the Neanderthal version of that gene, creating a relatively lower quantity of neurons in the brain than does the modern human version of the gene. So in that way as well, we seem to have brains that have a bigger capacity for complex neural networks, even though the overall size remains the same. So to sum up about the genes, we know that among the Neanderthals, there was an accumulation of deleterious mutations, suggesting smaller dispersed populations. There were about 40% lower fitness than modern humans, and greater areas of the brains were devoted to somatic function and vision. Modern humans seem to have brains with enhanced social cognition, more neurons, more connectivity. Now, this is probably what the social networks of the Neanderthal and modern humans look like. From both that genetic evidence and the archaeological evidence, it seems that Neanderthals were living in quite small groups. They were quite dispersed, and hence they had to rely on interbreeding, whereas the modern humans were forming larger groups, greater density, and had really quite intense social networks between them. So all of this leads us on to the question of language. We know that modern humans must have had language coming out of Africa. We suspect their language was as complex as ours today. Did the Neanderthals have language? And if so, what type of language? Well, archaeologists, anthropologists, linguists, psychologists have debated this for many, many years. But we know now, or there's a general consensus, that the vocal chapter of the Neanderthal, how they generated the sounds, was virtually identical to that of modern humans. We can do that by reconstructing using various anatomical bits of evidence. It is quite difficult because much of vocalization depends on soft tissue, like the tongue and the glottis, which, of course, we have no evidence for. But as a general consensus, the Neanderthals could make the same range of sounds as we could, and therefore they're likely to have had speech. And similarly, they could hear the same range of sounds. Reconstructing the audio track is a bit easier because it relies on small bones in the inner ear, and we've actually found some of those in excavations, like the malus here. And as far as we can tell, Neanderthal hearing was identical to ours today. So we think Neanderthals had the capacity for speech, the capacity for hearing. But the languages are likely to be different. If we look at the languages of people throughout the world today, we see there's quite a significant difference between the languages of those who live in small, isolated groups, where people are mainly talking between themselves, and those living in larger communities, when often you've got people coming and visiting who may speak other languages. The difference is that in the small populations, language is often much more complicated. Not simpler, but more complicated. They have much longer words, more morphology in them, higher degree of irregularity. Why do they do that? It's because they all know each other so well. They know the sort of knowledge somebody else has, so you don't need to actually tell them so much with your words. In larger populations, when you get lots of people visiting, languages tend to have a greater transparency. They're rule-based, they're easier to learn. So it seems likely that the Neanderthals had a rather complicated language, and modern humans had what we'd think is more transparent language today. I also think the nature of their words are different. Now, this is a theory I'm working on at the moment, looking at lots of linguistic material. But broadly, words fall into two groups. Iconic words, and the most familiar of those to us are onomatopoeias, plop, bang, pop, and so forth. But there's lots of other types of iconic words. You know, our words for small animals tend to be tiny little words like bee and ant, where the words for big animals tend to be large words like hippopotamus. So iconic words capture the sensory perception of the entity by the sound, the form of the world. Arbitrary words are symbolic words, like dog or chair. They're nothing like a dog or a chair. They're symbolic, they're arbitrary, and I think these are much more useful tools for thinking, for users' thought. What about symbols? Well, this is been a real change in the archaeological record over the last 20 years. We know now that both Neanderthals in Europe and modern humans in Africa began making symbols, material symbols, at about the same time. Use of pigments for colouring, whether it's colouring bodies or cave walls or objects. The use of beads or bird claws for making necklaces. From about 150,000 years ago, Neanderthals began doing that in Europe, just as Homo Sapiens were doing it in Africa. I suspect that reflects a stage at which their language evolutions have reached, that they've got to a similar stage, or the brain size has reached. But what's striking is that after 40,000 years ago, after the Neanderthals went extinct, and probably a bit earlier, humans developed a much greater symbolic capacity. Figurative art in Europe and also in East Asia, and also making images of imaginary beings, like this lion man here, or this sorcerer from Pievani cave, combining attributes of animals and people, probably supernatural beings. The Neanderthals never did anything like that at all. So I want to now come to an end and try to sum up what I'm thinking about the Neanderthal mind. Their brains seem to have had fewer neurons and more limited connectivity than those of modern humans. That said, they were experts at social interaction. They knew about animals. They can make brilliant stone tools. They were certainly extremely clever in particular domains of activity. Their artifacts were difficult to make, but very stable through time. They lived in small groups and therefore had limited variability in the overall pool of knowledge and skills there. And the languages were complex, irregular, dependent on pragmatics and iconic words. In contrast, the modern human mind, the brain seemed to have lots more neurons. They were more connected. It could create these imaginative ideas that then become expressed in material culture, like combining a man and a lion in this line here. They lived in much larger groups, so there was lots of variety and different sorts of knowledge around that they could draw on. And language had lots of arbitrary words that were then used for thought to build more concepts. So I summarize this by describing the Neanderthals as having a domain-specific mind. Lots of really expert knowledge, but they could struggle to bring this knowledge together. But the modern humans, we have a cognitive fluid mind. We're always thinking metaphors. We're always blending ideas from different areas. And we're continually creating new concepts. And you know, this is very interesting because here in Italy, this reminds us of the philosopher Giambattista Vico, who was writing in the 17th century. He was one of the first philosophers of mind, and he reacted against Descartes' view about rationality in the mind. And he said that the key thing about the human mind was this dreamlike imagination. And particularly he had the idea of the ingenual, the capability to create correspondence between things. And I think it's amazing that more than 200 years later, with all those advances in ancient DNA, all our discoveries about human evolution artifacts, we can actually go back to Vico and say, yep, you probably did get your finger right on it. What was the key thing about the modern human mind? So finally, what was in the mind of the Altamira man as he lay there, trapped in the cave, slowly passing away? Well, probably much the same as you and me. Thoughts of his family and friends that he'd miss. Maybe thinking of the times he spent singing and dancing, joyous times with them. I think he would have a more intense sense of loss about nature, more intensely losing an idea of being in the world surrounded by animals and plants and rivers and rocks. I think Neanderthals were much more engaged with the natural world than we are today. And I don't think he would have got any comfort from thinking that there was an afterlife coming. I don't think the Neanderthals, because of the domain-specific mind, had such ideas about supernatural beings and afterlife that would have required cognitive fluidity. So finally, it just leaves me to say that the Neanderthals are a fascinating type of human. They're dead. They'll never be forgotten because modern humans have curiosity, and of course that is exemplified by the Gabamo Science Festival. Science, we're trying to find out about the past, the present, and the future. And we're doing more so about the Neanderthals at the moment because, strangely, so much of them still survives within us today. Thank you very much for listening.
Grazie.
Thank you, Steve, for this journey into another humankind. There was another way of being humans on this earth. Ours was not the only one, and you covered the guess based on which we are the only humans on earth. I have some questions already, but we'll be asking also questions from the floor. And the one that comes to my mind immediately is that you showed the map with the Homo sapiens and his dispersal across the world. What was the difference in the occupation of the landscape? The Neanderthals were least migrant, least mobile than Homo sapiens. Was this due to the fact that Homo sapiens' intelligence was more imaginative, connected to storytelling, so they had a greater imagination, because oftentimes migration implies the fact of telling stories, having plenty of imagination, being capable of telling others what you saw. So was this another piece of the puzzle? That's why we were so successful in our migrations?
Yes, definitely. I mean, the modern human migrations is just remarkable. Okay, coming into Europe, fine, but I think even more astonishing is how they got to Australia, because not only did they move through South Asia into a tropical forest of Southeast Asia, having lived in Africa, then they must have built boats, substantial crafts to get across to Australia, a landmass that they couldn't have seen. So this is not only imagination that feeds into their technical ability to innovate, but a thirst for knowledge, a thirst for curiosity, a thirst to explore. And I think that, sadly in some ways, was lacking from the Neanderthals. They were really pretty rigidly fixed in a routine. Now, they must have had some forms of adaptation, because they did survive for a long period of time. But they just kept on making the stone tools, kept on doing these same things. So it was sort of like the lowest common denominator. This enabled them to survive, but they couldn't get out of the groove. Modern humans just kept getting out of the groove, getting into new grooves. And after the global migrations of whether to Australia, to the Americas, the next amazing thing modern humans did was invent agriculture. And they did that as soon as the Ice Age finished, in the interglacial about 10,000 years ago. And of course, that led to towns, cities, civilization, and so forth. The Neanderthals had lived through interglacial environments. They never did anything like that at all. So I think it does show this imagination, curiosity, desire to change. And you're right, storytelling is key to this, I'm sure. Telling stories about the past, but also telling stories about what the future could possibly be like. The stories that we all hear today, especially from our politicians, and who knows if they're going to be true.
Yeah, sure.
Another aspect that always strikes me is the ambivalence of the behaviors that you observe in Homo sapiens and you can't find in Neanderthals. For instance, when our ancestors, Homo sapiens, left Africa after a few thousand years, you found them in the Arctic Sea hunting mammoth, woolen mammoth, in an environment which was very different from Africa. And after another a couple of thousand years, you find them in Sulawesi with cave paintings. So the first behavior is very aggressive, trying to change their surroundings. The second one, the latter, more creative, again, cave paintings. My feeling is that when Homo sapiens leave their African country, everywhere they go, they change the landscape, they transform their ecological niche, they reduce biodiversity, they shape the environment that surrounds them. And this, in the case of Neanderthals, didn't happen. And so I'm being provocative here. Is this an indication of how little sustainable we are? Because we have been changing the world for better or for worse since when we left Africa for the first time.
Yeah, I think so. I don't think it was the modern human hunter-gatherers who are doing that. And of course, we must remember, it's not Homo sapiens. Up until 80,000 years ago, the Homo sapiens were very much like Neanderthals in terms of the tools they made and the regularity of the behavior. There was that cognitive change about 80,000 years ago. And certainly, when modern humans spread around the world, they did begin changing the environment. They had a much increased use of fire. They began building houses to live in rather than just using caves and so forth. But I think the big change comes with the origin of farming at about 10,000 years ago. I think that was the biggest mistake we ever made. I mean, in one way, it was the most fantastic mistake, because without farming, we wouldn't have towns and civilizations, we wouldn't have had Leonardo or Michelangelo or Bach and so forth of that. We wouldn't be here at the Bergamo Science Festival. On the other hand, we wouldn't have global warming either. We wouldn't have climatic change, because we start burning, we start removing forest for farming. We start this massive loss of biodiversity that's been increasing ever since. So I think that was a tragic mistake that modern humans made that we're still trying to cope with.
Sì, questa è una tesi molto...
This is a well-known thesis that agriculture gave rise to civilization, but was also our biggest mistake. My question is the following. This is connected to your project in Reading University concerning the relationship between cultural legacy and sustainable development, how we can use archaeology to try and understand how we related with our environment in the past and how we can do it in a better, more harmonious and wiser manner today. So archaeology as a function of a more sustainable presence of men in the world. Could you cover this project that is currently undergoing?
Yes, thank you for asking that, because many of the questions that we address in archaeology, such as the mind of the Neanderthal or the evolution of cognition in modern humans, seem to be purely academic. They're nice to know about, but they don't make much of a difference to the world today. But of course, some aspects of the past, we can learn from that in a really fundamental way. I work in the south of Jordan, where I excavate sites. Some of them are very old Neanderthal sites, some are from the start of farming. But what we can see in those desert landscapes is how people in the past had engaged with them in a far more sympathetic way, in a better way than we do today. If you look at the Nabatean civilization, for instance, they were brilliant water engineers. There was fantastic cisterns and dams and channels all over what's now desert. And they were ensuring that trees and woodland was surviving, because that helps maintain the water in the ground. Now, we seem to have lost that knowledge, but archaeology, by studying these ancient civilizations, might be able to return them to us. In another way, I'm also trying to develop a project in Jordan to help some of the local communities. In southern Jordan, some of the Bedouin tribes are extremely poor. They live in a very economically impoverished way. And yet there's some very large archaeological sites there, and American and UK and German teams have come and excavated them, then they've gone away and left, and the archaeology hasn't helped the local people at all. We're trying to set up some small businesses for the local Bedouins so they can make craft goods based on the archaeological artifacts we excavate, and walking trails around the archaeological sites so that tourists, eco-tourists, can come in, enjoy the archaeology, but then that can also benefit directly the very impoverished local communities. So I have a very broad view of archaeology, that it is about these, what we call curiosity-driven research, questions that are academically fascinating, but don't make much of a difference to the world today, but also impact-driven research, where we're trying to use archaeology to make a difference, to improve the livelihoods of disadvantaged people in the world. Whether we can exceed at either of those, I don't know.
È un progetto molto bello.
A very beautiful and interesting project that matches very well a new field of archaeology of climate change, how some populations could live in a more harmonious manner with the environment.
Facciamo domande di fiction. Se non ci fosse stata quella mutazione.
If that mutation in the gene TKTL did not place, if mutations did not happen, would the Neanderthals be still here with us together with Denisomans? And how would the world be with these three different human species, or would they have become extinct at a later stage? And so you're a pessimist.
Well, we do not know. I mean, I think that we may remember that the modern humans, they went through a very small bottleneck as well. It's estimated at the time there was maybe no more than 50, 100,000 modern humans around. They could have gone extinct as well. If modern humans had gone extinct, Neanderthals would have survived, Denisovans would have survived, Homo erectus would have survived. We'd be living in a world now probably of diverse human species. And that was indeed how the world was for the majority of human evolution. If you go back to, say, 300,000 years ago, we had Homo sapiens, we had Neanderthals, we had Homo erectus, Homo naledi in Africa, Denisovans. There's other humans out there that we know from the genes that we can't identify. These are all different ways of being human. So there's lots of different ways of being human. Our way has somehow had a selective advantage. But yeah, it could have easily gone the other way. So it might be one or two chance mutations. Had they not happened, or the mutation could have been in the Neanderthal line. So the Neanderthals might have developed the higher density neurons, the greater connectivity, and would be the extinct species. It's a fascinating think about what could have happened in the past in terms of chance and contingencies.
Ci è andata bene, insomma, dovremmo cercare di fare un po' più tesoro.
Yes, so we were lucky. We should maybe treasure this more. Now it's up to you. I see two hands raised already. I have a gentleman here with a phosphorescent jacket. We are Homo sapiens. We come from this. If we see how we've treated Native Americans or our history is a history of wars. We should exclude that sapiens, that violent actions of sapiens against the Neanderthals. Couldn't this have happened? Maybe there was no reason to quarrel because there was no density of population, but are there proofs? Is there evidence of a possible violent actions between us and the Neanderthals? I don't think there are signs of direct violence. It's been more of an indirect one, a slower process, right?
Yeah, thank you for the question. It's often tempting to think of the spread of modern humans into Europe and then coming into conflict with the Neanderthals in the way that the conquistadors did in South America with the Aztecs, or the Europeans in North America with the indigenous Americans. We don't know if that is a good model for it. We don't actually have any actual evidence for the direct contact. The closest we get is a modern human from Romania, and we know that his great-great-grandparents had been one Neanderthal and one Homo sapiens. So we don't have any direct hybrids themselves. And we don't have any evidence for a site where, say, Neanderthals have clearly been killed or butchered by Homo sapiens. I like to think that the interaction between them was a rather more consensual nature, really. I don't know whether that's wishful thinking or not. We can see that the Neanderthals probably had a lot to gain from interbreeding with the Homo sapiens because their populations were low. They needed to increase their genetic diversity. And equally, the modern humans, they seem to have had 2, maybe 3 failed attempts to get into Europe, and it was probably interbreeding that allowed them to do that. So I like to think that there was, it was a loving relationship between modern humans and Neanderthals, but who knows? We don't know. We may find some more evidence from new excavations. We don't know what fantastic new insights genetics might bring to us. It's a dilemma, but we don't have the direct evidence.
Arriviamo subito. Mi inserisco solo con una domanda.
I want to add a question because this is a very controversial topic. The war, the behavior of a group that intentionally attacks another. In human history, is it only after the Neolithic, before there are conflicts, but the war only starts when you have to defend a territory and an accumulation of resources of a territory? Or is this untrue? What do you think?
We certainly know that from the Neolithic onwards, there was a marked increase in intergroup violence. And that, no doubt, is partly about defending territory. When we look at fights between hunter-gatherer groups, they're often about display, shouting loud, showing off of weapons and headdresses, but not many people get hurt. Now, that's not always the case. We know that there is some tax and cannibalism and so forth, such as amongst the Papua New Guinea Highlanders. But generally, it's pretty low level. But farming definitely led to a marked increase in inter-society violence, because once you've cleared land and cleared forests, you invest in it. You need to protect it. Whether it changed the mentality of fighting, I suspect it probably did that as well, because I suspect there was much greater identity of your community, your society, and a sense of we are we and you are the other. And I think that's much more than existed amongst hunter-gatherers.
Quindi un'ipotesi ancora plausibile. Prego, ci sono 2 domande qua, in seconda e poi in terza fila.
Other questions? We have a young man there. A young girl, sorry. We spoke about the Neanderthal man, the Homo sapiens. Both come from the Heidelbergensis man. How did it become extinct? Because we spoke about the extinction of one and of the other, but we didn't really talk about where they were coming from, the common origin of the two.
Yes, that's a very good question. We can tell that the Homo sapiens and the Neanderthals shared an ancestor about 600,000 years ago by comparing their genomes. Because you can look at the rate of mutation that's occurred, and they take us back to about 600,000 years ago. And the key species that was living at that time is one called a Homo heidelbergensis. Now, we don't have any the genome at all of Homo heidelbergensis. And Homo heidelbergensis is, in fact, a rather indefined species. But you're quite right, that disappears from the archaeological record. And in fact, we think that Homo heidelbergensis maybe spread itself into Europe, and it gave rise to a species that we called Homo antecessor. That's especially found in Spain. Some think of Homo antecessor as a very early type of Homo neanderthalensis, and then it gradually evolved in Homo neanderthalensis. Or that again might have been a species that went extinct. But we know, looking at all animals, not just humans, that there's a turnover of species. Species do evolve and they become extinct after a period of time. So the Neanderthal extinction might have been just one of those regular cycles. And Homo sapiens may also have one of those regular cycles. But these early human ancestors, like Homo heidelbergensis, Homo erectus, they are still very mysterious. And we need a lot more research done on them to find out when they lived, how they lived, and when they became extinct. So that was a really excellent question. And Homo heidelbergensis is a really key species that we need to find more about. Thank you.
È una di quelle cose che devi scoprire tu adesso.
And you have to discover this in the next few years. We have another question in the second row there. Thank you so much for this conference, first of all. Thank you so much. Well, practically, as you said, primitive man lived in small groups. And I was told during a trip to Turkey 30 years ago that practically in this community, paternity was not recognized. So practically men, they tended to mix freely with others, and as a consequence, there was no family practically, whilst instead the man passes from being hunter-gatherer to becoming, to settle, let's say, instead of a nomad. He also becomes, not only does he become a farmer or a breeder, when he becomes a breeder, he realizes that if he keeps males separate from the females, there are no children. And at this point, the family was created. And what changes is also changes the importance between the man and the woman, because in that period the woman was considered as a superior being to man, because obviously apart from doing all of the other things, she also generated whilst the man did not. So this could also make me think, or make us think about another thing. If you have intercourse between the family relatives, if you inbreed, this could have contributed to the extinction of this species, because obviously it's not positive.
Yes, thank you very much. That's a very interesting view, a very interesting question. Trying to work out gender relations in the past is really quite challenging. Archaeologists across many disciplines, we've had a gender bias for years when it's been talked about men and hunting and so forth. But gradually we've come to appreciate that the role of women in these societies must have been as important, if not more so, at times. And it's not necessarily that we had the traditional family structures that we're familiar with now within these hunter-gatherer societies, whether Neanderthals or modern humans. And one thing I'm particularly interested in is with the role of women in playing a really key role in the evolution of language. Because we know that young girls pick up language much more quickly than young boys, and they're much more adept at language as well. So in these communities, trying to think about the male-female significance, the relations, we've got to guard against imposing our modern views onto the past. And of course, in these communities of early farmers, whatever, although they might be quite small communities, maybe 200-300 people living there, there was always movement and exchange of people with other communities around, which tended to guard against the inbreeding. That's typical of farmers. They live in really complex social networks. And I think that's a key difference from the Neanderthals, where there may have not been that exchange with other groups. So inbreeding just became much more prevalent. But it certainly looks like the inbreeding wasn't sufficient to push them into extinction by themselves, because we must never forget that Neanderthals did survive for more than 200,000 years in all sorts of environmental change. So we ought to call them a really successful species. Modern humans, if we date ourselves to 80,000 years ago, we've only lived half the time than Neanderthals, and we may well push ourselves into extinction before we reach that limit. Thank you.
Vediamo quanto
Let's see how we can resist, how long we can resist. The third row, please, this gentleman. Oh, there was someone else there. There is another question, please. Wait for the microphone. At the beginning of your presentation, you mentioned the tools that were being used by Neanderthals and what were the tools instead used by Homo sapiens. How can you tell the difference? What group used what tool and vice versa?
Well, we can certainly tell the difference because we have many archaeological sites where we find both the skeletal remains and also the stone artifacts with them. So we know that whenever we find Neanderthals, they're associated with a particular type of stone tools or stone tool technology, which involved making mainly large flakes, often using this technique called the Levallois technique, which is very difficult to use. And then when we find sites that haven't got skeletal remains, they also tend to date to the period of the Neanderthals. So when we can radiocarbon date them, or we can use other means of dating. Conversely, when we find modern humans in Europe, we find them with a different technology. They're also using stone nodules, mainly flint, but they're always associated with long, thin blades, and those blades were then changed into different types of tools, like arrowheads or spear points or scrapers. And that's a consistent relationship as well. So we've got good correlations between the species and the stone tools. And that's so strong that we're confident that when we find just the artifacts, we can attribute them to a particular species.
Good evening. My question goes back to the mutations you were mentioning. What is the significance of the TL gene that then modifies lysine as amino acid? What is the role of such a mutation in preserving Homo sapiens versus Neanderthal? I would think of neural complexity that could develop a language, a greater evolution than in Neanderthal, but mutations are very rare. One nucleotide over 100,000 can change or mutate. So per se, what could have been the impact of a mutation in the evolution of the species? Of course, we're talking about a long span of time. This might have had an impact in the field of mutations, I assume.
Well, thank you very much. This is one of the most recent discoveries. This mutation on this particular gene was only discovered, or at least published, I think 3 or 4 weeks ago. So it's significant to still yet to be digested by the scientific community. But the key argument is that this single amino acid chain leads to a different type of protein being developed, which in course leads to a higher density of neurons being developed in the brain matter. And the scientists involved have tested this. They've used mice and they've put both versions of the gene into mice, and they've measured the density of neurons, however they do that. And they said, yes, that is producing more neurons in the version that the modern human has than the Neanderthal has. And then they've also taken stem cells from human fetuses, and in petri dishes, they can grow what they call little brain organelles, which are like little mini brains, and they've fed those with the two different genes, and it also seems to have the same effect within these human stem cells. So the argument that's put forward is that when translated into the development of a whole brain, once the fetus fully develops, is that there'll be a higher density of neurons within the modern human brain than the Neanderthal brain. Now, quite what cognitive impact that has yet to be fully appreciated. But one can imagine that you could develop a more complex neural networks there, you've got greater processing power, and this might give a cognitive edge to the modern humans. But of course, it's yet got to be discussed and debated by the scientific community. Geneticists seem to be much the same as archaeologists and linguists. They don't seem to readily arrive at consensus in terms of what these are. But it's a fascinating discovery, and it's been sort of heralded in Nature and so forth as potentially indicating one of the key cognitive differences. I'm interested in that because when I argued almost getting on back in the mid-1990s that I thought modern humans had greater cognitive fluidity, cognitive capacity than Neanderthals, I didn't have any evidence at all from genes, from brains and so forth. So I'm really excited with this because it seems to be providing substance to arguments that I made just from the archaeological evidence. So you can imagine I'm quite keen on finding out about these findings. Thank you.
Sì, tra l'altro questo è un avanzo.
And this is a great advance in the methodology because we are currently using both archaeological, paleontological data, genetic data. We can see how organoids work. We can compare the ancient DNA of Neanderthals. So there's a lot of evidence, and this was not possible some years ago. There is another question here. Good evening. I really would like to thank you for your presentation, and given that evolution is your field of study, my question is the following, not much as to Neanderthal men because their brain and matter was different, their vocal apparatus was different from ours. But I'd like to ask, if we took an Homo sapiens a newborn 100,000 years ago, and we introduced them in our society, a family could raise this child, would there be differences between him and one of us? Would there be features that 100,000 years ago would have made him different from us?
Well, thank you. That's a brilliant thought experiment to have. My guess is that if we took a Homo sapiens, a tiny, tiny baby, or ideally an unborn infant or so, and could bring that into the modern world from 80,000 years ago, I think he or she would grow up just like us. I think there'd be the same ability to learn language, ability to engage with material culture, because through the cultural environment they're in, their brains would develop the same sorts of neural networks that we have for language and so forth. A more interesting question perhaps is if we could bring a Neanderthal child into a modern human society, how would that develop? Because, you know, we often talk about chimpanzees not having language, but those chimpanzees that we've put in laboratory conditions, and we've managed to teach them up to 200 or 300 words. So if you change their cultural environment, they can develop a capacity that they don't express in the wild. So I do wonder whether we could bring a Neanderthal into our human society, and it might grow up not quite like a Neanderthal. I still don't think it would be quite like a Homo sapiens, but I think some of the shall we say, the cognitive limitations would be compensated for by a greater use of material culture. And you know, one of the things that we emphasize in our societies today is neurodiversity. We all sort of recognize that we're all a little bit different in our brains and our ways of thinking and so forth. And I suspect Neanderthals would just be on, you know, be on the margins, but possibly not so far on the margins if they're in this, with this material culture that can sort of support them. You know, nowadays, we offload so much of our cognitive abilities. I can't remember any phone numbers, I don't know how to do much maths, because I just do it on my phone all the time. Give the Neanderthal a phone, an iPhone, show them how to use it. They might not have been that different from us, because you can offload this, and that's whole part of the extended mind. We're extending our minds further and further and further. Perhaps we're using them for different things. But maybe that would have been good for the Neanderthals. I don't know.
E con questo bellissimo esperimento.
And with this beautiful experimental thought, we really would like to thank Steve Mithen for being our guest today. Thank you very much, and see you soon.
Thank you very much indeed.